All right, we're going to talk through balanced chemical equations, especially if you weren't here for class. This will be helpful to you, so make sure you're walking along with the pencil and paper, okay? Let's make me smaller. Great, so balanced chemical equations. These are chemical equations with equal numbers of atoms for each element on both sides of an equation. Trying to move me. So remember that we talked about, or maybe this is just review for you, that there are two parts to a chemical equation. There are the reactants. And these things react together to form our products. Okay, and what we're saying is there are going to be equal amounts of things on this side and this side in a balanced chemical equation. So to start with, just some background information. Here it's asking how many atoms of each element are in NaHCO3. This is baking soda. And the way we solve this is we can take the chemical formula for the compound. This again is baking soda. And kind of like you do in algebra, we're just going to break down how much there is of each thing. So how much Na is there, how much H, how much C, how much O. This requires you to have a little bit of familiarity with the periodic table. Na again is sodium, H is hydrogen, C is carbon, O is oxygen. And let's start over here with O. Okay, so O has this 3 here. So it's going to tell us that there are 3 atoms of oxygen in this element. So take a moment and think about what the other ones might have. And what they all have are 1 of each. You might say, MB, that 1 wasn't there before. You're right. But remember in like algebra, for example, if you have something that just says X, you can imply that it is really 1X, but you don't need to write that 1, okay? So we don't need to have the 1 in there. We can take that out, just have our X, okay? So this is how we decide how many of each atom there are for an element. And just so that you know this as well, this in front of here, we could enter a specific number. We're going to call this the coefficient. And let's say that I put a 2 here. That 2 is now going to multiply all the way down the line. So now I have 2 sodiums, 2 times my 1 over here. I have 2 times my 1 hydrogen, so I have 2 hydrogen. 2 times my 1 carbon, so I have 2 carbons. And then 2 times 3, I have 6 oxygen. And that is in 2 of my molecules or compounds of baking soda. Okay? So that's some background information. Let's come here to try to balance this. So my suggestion to you when you're setting this up is to always start by deciding, or not deciding really, but just seeing how much of each atom there is to start. So I'm going to write on this side Zn, H, and Cl. Again, this requires you to know that Zn is one element, H is one thing, and Cl is one thing. If you come across stuff that you're not familiar with, just know that anytime there's a capital letter, it's a new element. Okay, that's just the way our chemical formulas, or the atomic symbols rather, go. Capital, lowercase, or just a capital by itself, H for example. Okay, so looking at this, I have 1 Zn, because I could put a 1 there, but I don't need to. It's implied that it's there. Okay, I have 1 H, and I have 1 Cl. This blank will fill in a moment, but for now, just 1, 1, 1. Okay, then I'm going to switch colors, come over to the other side. I'm going to say on this side, how many ZH, or Zn rather, that's zinc. How many H's and how many Cl's do I have? So I go again and look, and I have 1 of my Zn. I have 2 of my chlorine, looking at this number. And I have 2 of my H. Okay, so I look and I say, hey, it's not balanced. There's a problem here. And I need to make some sort of adjustment. So the places that I can adjust are just this coefficient. I can't decide, hey, you know what? I don't like that this is a 2. I'm going to put a 3. That's not something I can do because now I've made a different compound. It's no longer zinc chloride. It's still called zinc chloride, but it's a totally different compound. Okay, so I can't switch that. So what I'm going to do is I'm going to just try to see what I can balance by adding something in this coefficient space. So I see over here that I have 2 hydrogens and 2 chlorines. So I say, you know what, let's look over here. Oh, look it, this is where my hydrogen and chlorines are. What if I put a 2 here? If I put a 2 there, now it's 2 times the 1 hydrogen I had. So now, instead of having just 1, I have 2. And now instead of just having 1 chlorine, I have 2. And if I do a little check, yep, 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 yep. Okay, so that is zinc combining, or replacing rather, in hydrogen and chlorine. That's hydrochloric acid, and then it's making zinc chloride and just hydrogen by itself. So this is now balanced. Let's come to this one. Same process. So I'm starting with just 1 of my irons, Fe, 2 of my oxygens on the left, and then on the other side I have 2 irons and 3 oxygens. And it's kind of just a little bit of trial and error until you start to figure it out. So I'm going to look here and say, you know what, let me see about making this where I have 2 irons on this side. So now I have 2 over here. So I solved that problem. However, I haven't solved this oxygen problem. You could try a number of things. I'll give you a little bit of a hint here. This should really be 4. And if that's 4, now the number of irons I have is 4. I need this iron to also be 4, so I'm going to put a 2 here. 2 times the 2 over here will give me 4. So now I have 4. 2 times the 3 over here for oxygen will now give me 6. With that, I'm going to come back to this side and say, all right, I have 2 here. How do I get to 6? I'm going to put a 3. 3 times 2 is 6. Obviously, I've been doing this for a little bit of time, but you just kind of get used to the trial and error of it, and you start to see patterns and how you can make adjustments. And again, just keep trying stuff out, see what works. If you were here for class and you just needed the review, that is all you need. If you weren't here for class, I'm going to scroll down and make sure you get these 2 additional vocab words. You can add those to your notes. You need to know that a mole is a unit of measurement for an amount of substance. Specifically, it's this really large number right here, 6.022 times 10 to the 23rd. We don't really use that number a lot here, but if you take high school chem or AP chem, you'll see it there. And I know it's a bit intimidating, but really this is just a number, kind of like how a dozen eggs means 12 eggs, or a gallon of milk is that many liters. 1 mole is just a whole bunch of atoms, 6.022, so 6 with 23 zeros after it, really big number, amount of atoms. And we use this as a way to communicate about how much of a substance there is with this mole ratio, which is the ratio of reactants and products in a balanced chemical equation. And we're going to use the coefficients that we found, those numbers in the front, as the way to give us that ratio. So for example here, they're giving you the A and B ratio. So there is 5. Ooh, it's not what I wanted to do. Let's come back a second. There are 5 of our oxygens. There's nothing written here, so there's really just a 1, and there's 1 of the propane, so I have a 1:5 ratio of propane to oxygen, meaning that if I want a complete reaction, I need 1 mole of propane and 5 of oxygen, and then I will make 3 moles of carbon dioxide and 4 moles of water. We'll use this in our project, but this is the mole ratio, and you should know that.